This is the new 3-liter all-aluminum V6 turbo diesel engine with a high-pressure common rail and direct injection. It's built at the Mercedes-Benz engine plant in Berlin, Germany, and is currently in production in Europe. However, the first application in North America will be the 2007.5 Jeep Grand Cherokee. Later in the 2007 model year, the 3-liter engine will also launch in the Dodge Sprinter, which carries the body code VB. Hello and welcome to MasterTech. In this month's program, we're going to introduce you to some of the notable and unique service features of the all-new 3-liter turbo diesel engine and fuel system. The main focus of this program is the Grand Cherokee application. However, along the way, we'll inform you of some of the minor differences between the Grand Cherokee and Sprinter applications. We'll begin with a general overview of the engine, followed by some general precautions and service features that you'll need to be aware of when servicing the new 3-liter engine. Next, we'll discuss the intake and fuel systems, then the cylinder head covers and heads, the block, and finally, the exhaust system. Clearly, there's a lot of information to cover, so let's get the April program underway with an overview of the all-new 3-liter turbo diesel engine. Accurate identification of the 3-liter turbo diesel engine is fairly simple. Just look for the engine identification number, which is stamped on the front left side of the engine block below the cylinder head. If you know how to read it properly, the engine identification number will tell you the engine model, the engine type, the engine plant code, and the production number. As you already know, the displacement is 3 liters, and the all-aluminum V6 turbo diesel engine has a high-pressure common rail and direct injection. The new engine is currently rated at 215 horsepower at 4,200 RPM and 376 pound-feet of torque at 1,800 RPM. The compression ratio is 18:1, and it has chain-driven dual overhead camshafts, 24 valves, and a balance shaft that counteracts engine vibration. The engine controller is built by Bosch, and for the Jeep Grand Cherokee application, the controller is located below the battery tray. On Sprinter, the controller is located on the left front fender, and if the vehicle is equipped with an auxiliary battery, the controller is located below the auxiliary battery tray. The 3-liter diesel engine complies with 2007 Environmental Protection Agency emission regulations in 45 states in the Grand Cherokee application and in 50 states for the Sprinter application. To meet these standards, the 3-liter diesel engine requires ultra-low sulfur diesel, or ULSD fuel, and low-ash diesel engine oil. We'll have more information about these as we discuss them during the program. Right now, let's take a look at a few of the general precautions and service features that you'll need to know about prior to servicing the 3-liter diesel engine. The 3-liter diesel engine makes use of a high-pressure common rail fuel system. The high-pressure fuel injection system in the 3-liter diesel engine can develop pressure in excess of 23,200 psi. Fuel at this pressure can injure or kill, so it's important to observe all of the high-pressure fuel-related safety precautions and read all of the warning statements in the service information. A couple of these safety-related items include never opening high-pressure lines while an engine is running, and always using a piece of cardboard or other suitable material when checking for high-pressure leaks. General service features of the 3-liter engine include a large number of bolts that cannot be reused. If you have a question as to whether or not a bolt can be reused, consult the service information. There are several matched components in the 3-liter diesel engine. This means that if a component requires replacement, there may be one or more related components that must be replaced at the same time. We'll point out some of these matched components during this program, but you should always refer to the service information to ensure that you know exactly what a repair entails. Now, The last general feature that we want to alert you to in this section involves gaskets. Actually, the lack of gaskets. Most of the gaskets in the 3-liter engine have been eliminated. For example, instead of a gasket, a bead of black engine RTV sealant is used to seal the timing cover to the engine block. The timing cover also has 2 lower guide pins that must be removed and discarded when sealing the timing cover to the engine block. This is to avoid damaging the sealing bead when the cover's installed. The cylinder head covers and the oil pan also have no gaskets. Black engine RTV is used in these locations. We'll inform you of some of the special precautions you'll need to take in these areas as we discuss them during the program. But as always, you should refer to the service information for details regarding all of the sealing surfaces on the 3-liter diesel engine. Next, let's begin our review of the 3-liter diesel engine by taking a closer look at the intake system. The intake system on the 3-liter diesel engine is made up of several components. Let's begin with the mass airflow system. The MAF sensor is mounted to the air filter housing and is used to calculate the air mass flowing past it. The primary purpose of the MAF sensor is exhaust gas recirculation flow control. Another intake system component that you need to be familiar with is the variable geometry turbocharger, or VGT, as it's sometimes called. Probably the first thing you'll notice about the turbocharger is that the location is unique. It's located at the rear of the engine above the intake manifolds, and a shield is used to protect the surrounding components from excessive heat. The VGT design varies exhaust gas flow rate with adjustable deflector blades that alter the size of the gap through which the exhaust gas flows to reach the turbine. Basically, here's how they work. At lower engine speeds, the turbine vanes close. The exhaust is directed toward the end of the vanes, giving it more force. It also produces faster exhaust gas flow through the turbocharger and results in an immediate increase of turbocharger boost pressure and less turbo lag. This enables the engine to produce more power when needed for acceleration. At higher engine speeds, the turbine vanes open and the airflow strikes the center of the turbine. When the turbine vanes are open, the speed of the exhaust past the vanes decreases, which prevents boost pressure that is higher than it needs to be. As you probably already know, turbochargers create large amounts of heat and require a cool-down period after operation. The VGT is no different. The owner's manual contains a helpful turbocharger cool-down chart that you can use for reference. The last intake system related topic that we want to cover with you is the exhaust gas recirculation, or EGR system. The purpose of exhaust gas recirculation is to reduce nitrogen oxide, or NOx, emissions by lowering the oxygen concentration in the combustion chamber, as well as through heat absorption. One critical part of the EGR system is the EGR airflow control valve. The EGR airflow control valve adjusts the flow of fresh air into the engine during EGR operation. A signal from the ECM controls the operation of the EGR airflow control valve and the EGR valve. The position of the EGR valve and the airflow control valve determines how much exhaust gas needs to be recirculated to reduce emissions. A charge air crossover is also part of the EGR system and is located between the EGR airflow control valve and the intake manifolds. The charge air crossover mixes the flow of fresh air from the EGR airflow control valve with exhaust gases coming from the EGR system. The mixed air is distributed to the left and right side intake manifolds. Another notable feature of the EGR system on the 3-liter diesel engine is the EGR cooler. The purpose of the EGR cooler is to reduce the temperature of the recirculated exhaust gases. For the Grand Cherokee application, the EGR cooler is located in the cylinder block valley, below the intake manifolds and just above the engine oil cooler. For the Sprinter application, the EGR cooler is located on the right side of the engine, bolted to the cylinder head. On Sprinter, the EGR cooler also includes a bypass valve. This is for improved emissions because the EGR bypass valve can route exhaust gases away from the EGR cooler when necessary. Finally, note that on the 3-liter engine, to reduce the operating temperature of the EGR valve, the valve has its own coolant feed. Now, let's continue our review of the 3-liter diesel engine by taking a look at the fuel system, beginning with the fuel filter. On the 3-liter diesel engine, the fuel filter is mounted on top of the engine, underneath the engine cover. The fuel filter includes a water separator and a water and fuel sensor. On Grand Cherokee, the water separator drain is located directly on top of the fuel filter. On Sprinter, an extension tube is routed from the drain to the right side of the engine, close to the EGR valve actuator. The procedure for draining the water separator is nearly identical between the Grand Cherokee and Sprinter applications, with one exception. To access the drain on the Grand Cherokee, you must first remove the engine cover and the turbocharger inlet tube. The engine cover cannot be simply pulled off of the engine, similar to many other engine covers currently in production. To remove the engine cover on Grand Cherokee, you must remove 2 fasteners and pull the cover forward and away from the rear hooks. Once you've removed the engine cover and turbocharger inlet tube on the Grand Cherokee, you'll need to attach a hose to the drain valve to avoid spilling fuel. Next, turn the ignition switch to the on position to activate the in-tank electric fuel pump. The pump will run for approximately 25 seconds. Then, turn the drain valve counterclockwise and collect the fluid in an appropriate container. The heart of the fuel injection system is the high-pressure fuel pump. The high-pressure fuel pump is mounted to the front of the left cylinder head. The pump gear is driven by the intake camshaft sprocket at 1.6 times the speed of the camshaft and requires no timing. Care must be taken if you're installing the high-pressure fuel pump when the camshaft cover is in place. Do not force the pump into position. It cannot be tapped with a hammer or even a rubber mallet, as this will cause damage to the pump gears. Never use the bolts to draw the high-pressure fuel pump into position, as this will damage the pump. The fuel quantity solenoid and the fuel pressure solenoid work together to supply the system with the correct amount of fuel at the correct pressure. The fuel quantity solenoid is located on the high-pressure fuel pump flange, and this is a serviceable item. The fuel pressure solenoid is located on the left side fuel rail at the front edge. This is not a serviceable item and is only available as an assembly with the fuel rail. The fuel rail pressure sensor on the right side fuel rail is available as a separate serviceable part. The high-pressure fuel pump is not responsible for fuel injection timing. In fact, its only job is to produce the correct amount of high-pressure fuel. Fuel passages and control elements in the pump flange located at the back of the pump regulate the flow of fuel to the high-pressure pumping chambers and control the lubrication of the pump. Diesel fuel is the pump lubricant. Because the pump is lubricated with diesel fuel, cranking the engine for an extended period of time without a fuel supply may damage the high-pressure pump. So after replacement of the high-pressure pump, the ignition must be switched on for at least 15 seconds to properly lubricate the pump. For service, the high-pressure fuel pump and its flange are supplied as an assembly. The high-pressure pump must not be disassembled or opened because the only serviceable items are externally mounted, the temperature sensor and the fuel quantity solenoid. The final component to cover with you in regards to the fuel delivery system is the fuel injectors. The 3-liter diesel engine makes use of a piezoelectric injection system. The piezoelectric effect is where the application of a bending force to a crystal material causes it to generate a small amount of voltage. The fuel injectors on the 3-liter diesel engine make this effect work in reverse. When voltage is applied to a piezoelectric crystal, its dimensions change. It bends. The piezoelectric stack in each injector contains more than 350 layers of piezoelectric material that change dimensions when voltage is applied. This produces a significant change in length, which starts the injector opening sequence. Notice that each injector has a high pressure feed and a low pressure feed. There is no measurable fuel return from the injectors. Therefore, there is no test for fuel return from the injectors available. Whenever you are servicing the fuel injectors, you should always replace the copper seal ring and the retaining bolt. Also, remember to lubricate the body of the injector with Mopar anti-seize. Mopar part number 04773-257. Next, we're going to take a look at the cylinder covers and heads. Let's begin our look at the upper end of the engine with the cylinder head covers. On the 3-liter diesel engine, the cylinder head covers and the cylinder heads are not individually serviceable. They're replaced as a matched set because the covers also serve as the upper bearing surface for the camshafts. The cylinder head covers are one of the areas mentioned earlier that have no conventional gaskets. Instead, black engine RTV is used to seal the covers to the cylinder heads. A heat gun is required to properly remove the cylinder head covers without causing damage. Service information will provide you with details regarding the proper procedure for removing the covers using the heat gun. The cylinder heads on the 3-liter engine have some other features worth noting. They feature a cross-flow design and are constructed of high-strength cast aluminum alloy, holding 4 valves per cylinder with pressed-in valve guides and valve seats. The cylinder heads also include the roller finger followers and lifter assemblies. The lifter assembly must be replaced if the camshaft is replaced. However, if you must replace the lifter assembly, you may not need to replace the camshaft. Since the cylinder head covers provide the upper camshaft bearings, the camshafts must be secured with special tool number 9555 when turning the engine with the cylinder head covers removed. The crankshaft ventilation system is another notable 3-liter engine feature. The system consists of a centrifugal oil separator or centrifuge and a crankcase pressure control valve. The centrifuge is mounted to the right bank intake camshaft. It's designed to separate the oil from the blow-by gases and return the oil to the crankcase. The crankcase pressure control valve is located at the back of the right bank cylinder head cover. It's designed to prevent high intake vacuum from drawing excessive oil from the crankcase. If a vacuum of more than 50 millibar exists in the charge air line, the connection to the crankcase is sealed off by the diaphragm. The intake manifolds on the 3-liter diesel are yet another distinctive feature of this engine. The intake manifolds feature swirl intake ports for more efficient combustion and reduced particulates in the exhaust at low engine speeds. Each manifold incorporates 1 swirl port and 1 charge port for each cylinder, and the swirl ports can be closed by the swirl valves. The valves are connected via linkage, which is operated by the swirl valve actuator, located in the valley of the engine behind the fuel filter. The swirl valves are serviced as an assembly, and the fault codes for the swirl valve actuator will be stored in the ECM. Next, we'll cover some of the notable features of the 3-liter diesel engine cylinder block and a few other related components. The 3-liter diesel engine uses a deep skirt aluminum cylinder block with cast-in dry cylinder liners that are splayed at 72-degree angles. The cylinders are numbered front to back, beginning with the right cylinder bank. The right bank cylinders are numbered 1, 2, and 3, and the left bank cylinders are numbered 4, 5, and 6. So the injection order of the 3-liter diesel engine is 1, 4, 2, 5, 3, 6. You should also know that the cylinder liners are not serviceable. The Grand Cherokee and Sprinter each use a unique aluminum oil pan. The Grand Cherokee oil pan is a one-piece design, and a two-piece oil pan is used on Sprinter vehicles. An oil temperature sensor is mounted to the oil pan near the oil drain plug on Grand Cherokee, and Sprinter uses a multifunction oil condition, temperature, and level sensor that's mounted on the right side of the oil pan. The aluminum oil pan is another area where the service procedures for the 3-liter diesel engine differ from most other engines. The rear main seal carrier is fastened to the oil pan, so the transmission must be removed prior to removing the pan from the block. However, before you get to that point, you should know that similar to the cylinder head covers, the oil pan does not use a conventional gasket. Instead, black engine RTV is used to seal the oil pan to the cylinder block. Similar to the cylinder head covers, a heat gun is required to properly remove the oil pan without causing damage. Within the aluminum block is a forged steel crankshaft that has 9 counterweights for balance. The crankshaft is what's described as a splayed design with 6 separate throws arranged at different angles to reduce second-order vibrations. The 3-liter diesel engine also uses a balance shaft located within the cylinder block above the crankshaft. The balance shaft is chain-driven by the crankshaft and is used to counteract engine vibration. The balance shaft rotates at the same speed as the crankshaft, but in the opposite direction. The crankshaft cannot be machined. It can only be replaced. If you do need to replace the crankshaft, there is a special coating process that you'll need to know for the bearing selection process. The service information contains the details for crankshaft bearing selection. The connecting rods are a cracked cap design. However, they differ from the cracked cap connecting rods you're probably already familiar with. On the 3-liter diesel engine, if a connecting rod bolt is removed or even loosened, you must replace the entire connecting rod assembly. And all 6 connecting rods must be replaced at the same time in order to maintain proper engine balance. Another area on the cylinder block that requires extreme caution during service is underneath the main oil gallery, specifically the oil jets. 3 dual nozzle oil jets are bolted to the cylinder block underneath the main oil gallery. The jets connect to lubrication passages, and each oil jet helps cool 2 opposite pistons. It's imperative that you do not remove or bend the oil jets because they cannot be replaced or repaired. If an oil jet is removed, bent, or damaged in any way, the entire long block assembly will need to be replaced. You must use extreme caution when removing or installing the connecting rod assemblies, as they're very close to the oil jets in the main oil gallery. An oil cooler is located in the valley of the cylinder block below the EGR cooler. 2 gaskets seal the oil cooler to the cylinder block, and you should replace the gaskets whenever the oil cooler is removed or replaced. The oil filter is located at the left front of the engine. For service, special tool number 9551 is necessary to remove the oil filter cap. Be sure to loosen the oil filter cap prior to draining the oil pan, because there's a notable amount of oil in the filter housing that will not drain into the crankcase until the cap is loosened. When servicing the oil filter, always replace the seal ring and lubricate it with a very thin coat of oil. The seal ring on the cap will tend to roll, so use caution when installing the oil filter and tighten the cap to the proper specification. Use only the appropriate grade of low-ash engine oil to maintain the expected life of the exhaust after-treatment system. Synthetic 5W30 low-ash diesel engine oil with an API rating of CJ4 is what's recommended for the 3-liter diesel. Another word of caution regarding changing the oil in the 3-liter diesel engine. The oil takes approximately 10 to 15 minutes to make it all the way down into the oil pan after the engine is shut off. You must wait at least 15 minutes to check the oil level on the dipstick for a proper reading. Next, we'll conclude our review of the 3-liter diesel engine by looking at the exhaust system and some of the related after-treatment components. One unique feature of the 3-liter diesel engine's exhaust system is the diesel particulate filter, or DPF. The exhaust system contains a close-coupled pre-catalyst, a main oxidation catalyst, a diesel particulate filter, and a muffler. The diesel particulate filter is installed for exhaust gas aftertreatment. The DPF filters and stores particulate matter in the form of soot that's generated during the combustion process. The soot is oxidized at exhaust temperatures that reach over 1,000 degrees Fahrenheit or 600 degrees Celsius during an event called regeneration. The residue that remains inside the diesel particulate filter after regeneration is non-burnable ash. Over time, ash accumulation will require the replacement of the diesel particulate filter. That's why the use of low-ash diesel engine oil and ultra-low sulfur diesel fuel are so important in this application to keep the buildup to a minimum. The ECM monitors the pressure on both sides of the diesel particulate filter to determine DPF performance and to determine when a regeneration event is necessary. There are 3 types of regeneration. The first is passive regeneration. This type of regeneration occurs during normal drive cycles and requires no action by the operator or the ECM. The next type of regeneration is called active regeneration. If the passive regeneration cannot keep up with the buildup of soot in the diesel particulate filter, the engine control module will modify fuel control to burn off the excess soot. The third and final type of regeneration is called manual regeneration. Faults may be recorded by the ECM that will require a manual regeneration procedure. The EVIC will inform the operator when service or maintenance of the diesel particulate filter is necessary. The StarScan or Star Mobile can be used to perform a manual regeneration of the diesel particulate filter and to clean and calibrate the system. Manual regeneration of the diesel particulate filter produces extremely high temperatures in the exhaust system, which can damage the exhaust extraction system hoses in the shop. A manual regeneration should only be performed in an open outside environment. Be sure to refer to the service information for a complete up-to-date list of all warnings and safety procedures associated with the manual regeneration procedure. For additional training focused on the all-new 3-liter turbo diesel engine and fuel system, we recommend that you visit the DCA Learning Center website and enroll in course number 104-0316, Diesel Engine Repair, or in course number 105-0616, Jeep Diesel Fuel and OBD2 Systems, Phase 1. Well, that's all we have to share with you regarding the all-new 3-liter turbo diesel engine and fuel system. Be sure to join us next month when our topic will be a drivetrain update. Thanks for watching.